This next section gets into inverse trigonometric functions. But before we get into those, we want to review what inverse trig functions are. So to start off, when is a relation a function? And this is when each x is paired with one y. Each x is paired with one y. What type of relation is not a function? Well, that's when the domain goes to more than one value in the range. The domain goes to more than one value in the range. And where you've seen that most often is a failed vertical line test. If you draw a vertical line and it crosses a function or a graph twice, you can't say it's a function because then for a single x value, you would have two different y values. So what is an inverse relation? And given a function, how do you find its inverse relation? The idea here is that you switch the x and y values. Your domain becomes your range, and your range becomes the domain. So the domain becomes the range, and the range becomes the domain. And every function has an inverse, but not inverse is necessarily a function. And why can this be? And it goes back to the idea of the horizontal line test. If you can draw a horizontal line through your original function, and it doesn't cross your function more than once, you know the inverse will also be a function. Here's a traditional example of something that does not work. You've got a parabola. And when you've got the parabola, you can see it passes the vertical line test at any given point. So the parabola itself is going to be a function. But let's say you take the inverse. You switch all the x's and y's, you end up getting a parabola that's on its side. And you can see here clearly that it fails the vertical line test. So not every single inverse is guaranteed to be a function. It's only going to be a function if the original graph passes the horizontal line test. So if a function has an inverse, it's going to be defined as f inverse of x. And specifically with our trig functions, sine, cosine, and tangent, we can write those as sine inverse of x, cosine inverse of x, and tangent inverse of x. However, that can get really confused with the reciprocal, so we write it in another format. We're going to use the term the arcsine, the arccosine, and the arctangent. Sine inverse is the same thing as arccosine, cosine inverse is the same thing as arccosine, and tangent inverse is the same thing as arctangent. If we use the arcsine, arccosine, and arctangent, we are less likely to get confused with reciprocals. The final thing you looked at with inverse relations and how you graph them with respect to the original function is how is it related with the line y equals x? And the simple answer is that the graph reflects around y equals x.